A Wilson cloud chamber is a radiation detector that works visually to allow you to physically see radioactive decay. And it was invented by C.T.R. Wilson.
Wilson discovered the cloud chamber device in the late 1800s to early 1900s while he was working at the University of Cambridge.
The Wilson cloud chamber was actually discovered almost by accident, while Wilson, who was a meteorologist, was attempting to study cloud conditions on mountaintops. To do so, he devised a chamber that would create a supersaturated environment. Eventually, he realized that this environment allowed the physical observation of the passage of subatomic particles. When he realized its scientific potential, he spent 20 years attempting to perfect it. It became hugely important in the study of radioactivity, nuclear physics, and various physical principles, especially as a teaching demonstration to comprehend difficult phenomena. He went on to win the Nobel Prize for the Wilson cloud chamber in 1927 alongside Arthur Compton.
This is a photograph of Wilson's original cloud chamber, perfected in 1912, taken in Cambridge, England at the Cavendish Laboratory Museum. The large spherical glass bulb on the right is actually a vacuum chamber used to control the cloud chamber. The cloud chamber itself is the wide glass cylinder that sits atop the wooden cylinder. In fact, the cloud chamber has the basic shape of a petri dish, and we're going to use a simple petri dish to make a modern and much simpler version of this apparatus.
So to make a Wilson cloud chamber, we took a petri dish and lined it in adhesive felt along the bottom as well as along the sides with tape, and then took a pipette and isopropyl alcohol and soaked just the edges of the chamber to take a alpha radioactive source, this is polonium-210, and place it in the center of the chamber, close the lid, and place on top of dry ice. The Wilson cloud chamber works by creating a supersaturated environment where alcohol is quickly reduced in temperature by the dry ice, which generates a temperature gradient with cold vapor on the bottom and room temperature vapor on top. The isopropyl alcohol stays on the verge of condensation while remaining a vapor, so that the radioactive decay coming from the alpha source is visible because the emissions disrupt the balance between vapor and condensation by triggering condensation in small trails following the charged subatomic particles being emitted.
While Wilson could see cloud tracks for alpha, beta, and gamma radiation, and even X-rays, we tried a number of different radioactive sources, and were able to get a clear view of alpha radiation only. This is polonium-210, showing thick white tracks just above the bottom of the chamber, emanating outward from the center of the source. If you are able to see beta or gamma radiation, they will probably appear as thinner, thread-like cloud tracks. Thanks for watching from the Randolph-Macon College Society of Physics students, and good luck making your own Wilson cloud chamber.